look at this problem. We have to find two prime factors of this really big number. Seems pretty simple, right? Well, it's not. Even one of the fastest supercomputers will take years to solve this. Solution: quantum computer.
But what is a quantum computer? Is it just a super fast, super accurate version of a classical computer like the one you are using right now? Not really. Quantum computer is fundamentally different from classical computer. A classical computer uses bits for performing operations, while a quantum computer uses qubits. A bit exists in either of the states 0 or 1, while a qubit can exist as a 0, a 1 or a superposition of 0 and 1. What is superposition, you ask? Consider this coin. Right now, this coin's state is in a superposition of heads and tails. But when I observe, oh, it's heads. Now let's see how this property of qubits makes computing faster.
This maze has 8 possible paths, only one of which will lead us to the exit. A classical computer would check each path one at a time. While a quantum computer would check all the 8 paths at the same time using just 3 qubits, because 3 qubits exist in 2 to the power 3 8 states.
Wow! Quantum computers will make your life so much easier. Let's use quantum computers.
Whoa, wait. It's not that easy. Quantum states are fragile and hard to measure because their state changes when measured. Let's see. Imagine this is a stream of photons and this is a filter which is aligned vertically. When all the photons are vertically polarized, they pass right through the slit. When all the photons are horizontally polarized, they do not pass through the slit at all. But what happens when the photons are polarized at a 45-degree angle? Let's see. What happened? Only half of the photons passed through and they all came out vertically polarized. That means their state changed on measurement. Also, we cannot predict which photons will pass through and which will be blocked. That means we cannot predict which qubits will be lost during transmission or measurement. Also, quantum states are greatly affected by environmental factors like by even slightest vibrations.
But why all this effort? Quantum computers have important applications in drug development, artificial intelligence, weather forecast, cybersecurity, and much more. Quantum computers are the future, and we only want our future to be better than the present. Don't